Tonight we're trying to show that this huge number is composite or is not a prime. And let me give you an example of what we'll be doing right here. 18 is equal to 3 times 6, right? And so that means 18 is what we call composite or not prime. And obviously 3 and 6 are both greater than 1. Okay. Like that. Okay, so that idea is going to get used at the very end here. We'll get an expression that discernibly produces two factors that are greater than 1. Okay, now these two identities are going to come in quite handy. And what we do at the very beginning right here is we just rewrite the term, the expression we're trying to show is composite using the properties of exponents. 2 times 30 is certainly 60, and then 2 times 26 is certainly 52. And so we're getting it in this squared sort of expression that will be amenable to these well-known algebraic identities. Okay. Now the next thing we do, which is kind of mysterious, but it's highly motivated if you just take a look at it. You see this circled object right here? That's just equal to 0. Okay, so in other words, we still have an equivalent equation. That whole thing's just equal to 0. All right. Now, so why did we do that? Well, it's kind of like looking into your crystal ball, but you'll notice right here that this expression right beneath it is in the form a plus b. Okay, and of course it's quantity squared. Okay, I'll go ahead and put that in there. A plus b quantity squared. Okay, and you can look right up here and see that because this would be your a squared right here. Okay, and then this object right here would be your b squared. And then this piece right here would be your 2ab. Okay, sorry about that, 2ab inside of there. Okay, so you see that's exactly what's going on. And notice that all that's left now is just this straggler. You know, there was 2 copies of it, but it got gobbled up by this identity, right? And so now we're down to this stage. All right, but you can recognize this as the difference of 2 squares. Now let me come down, make sure I think I left myself enough room here. This is definitely in the form a squared minus b squared. Now I didn't explicitly write this down, but you can see that this object right up here, this would be 2 squared, this would be 7 to the 15th squared, this would be 9 to the 13th squared, right? And now you can see where this very next line came from, okay? This whole part right here, let's see, do I have everything together here? Yeah, this whole piece right here would be like your a plus b, right? In other words, if you take a look at what I have right here, I have 7 to the 30th plus 2 times 9 to the 26th, right? So this part this whole object right here, let me see if I can make it big enough. This would be like the a, and then this piece right here would be your b. And that's sort of hard to see, but that's what makes these things fly. In a similar fashion, you would have a minus b right here. I'm trying to keep it underneath what it's relevant to. Okay, guys? And I hope this is a clear explanation. I hope it makes sense. Now, technically, I would think right now you could say you're done. This object right here certainly has to be greater than 1, and so does this object. So you could say you'd proved that this expression, the original expression, is composite. But you can make it slightly cleaner right down here. If you take a look right here, notice that this is in the form, if you think of this as a plus b squared, a squared would give you this 7 to the 30th, right? Okay. Okay, and then b squared would give you the 9 to the 13th, or excuse me, your 2ab would be this part right here. Your 2ab would be this part in this expansion a plus b squared. Let me just, well, I hate to write it down because, well, I think you guys see it. This is a plus b quantity squared, right? So a squared would give you this term right here. B squared would give you 9 to the 13th only, 9 to the 26th once, right? But we have 2 of them here, right? Y'all see that? So that's why we have to do another 9 to the 26th. So again, if you think of this as a plus b squared right here, and I'll just do that. I'm a little hesitant because I don't want to make it too messy, but if you think of this object right here as a plus b quantity squared, it leaves out something, so to speak. Okay. You get the 7 to the 15th. No, 7 15th goes to 7 to the 30th, right? And then 9 to the 13th squared is 9 to the 26th. But there's 2 of them up here, you see? There's 2 of them up here. That's where this one comes from. We kind of correct our mistake. This part right here would be the 2AB, right? And I don't want to write it because it'll be too messy. I don't want it to get too confusing. But in any event, and something similar happens over here. But what we have shown definitely is we have 2 factors. This factor, this entire factor here is certainly greater than 1, right? It's overkill, really, but those numbers are so huge you never know. I mean, large numbers can be prime, right? So anyway, y'all, we have completed the proof. We're done. QED, if you want to call it that. And by the way, y'all, this is called the Sophie Germain identity. And she was, I think, a contemporary of Fermat and was very interested in primality testing and I think Galois theory, you know. But anyway, I hope that made sense. I hope the algebra was okay. Let me know what you thought and talk to you later.